Hello everyone, welcome to my presentation. My name is Kwan Amin, and today I'm going to give a presentation on the research paper Development of the Robotic Sorting System for small parts using SCARA robot. This research article was written by a group of Korean authors and will be presented by me. My presentation is divided into four main sections. First of all, I will talk about the introduction, which provides an overview of the research. Secondly, we will look at the methods. In this session, I will show how the research was performed. Thirdly, I'm going to talk about the result which describe the data that were collected and the result of tests that were performed. And finally, I will show you the conclusion and summarize the results that were obtained in study. Now let's move on to the next slide. Recently, the output of camera module has rapidly increased for the security of cameras, sight and zoom functions, wide angle, ultra-wide angle, telephoto, and ToF are applied to smartphones by combining many specialized features for ultra-thin cameras. In order to reduce the thickness and size of smartphone equipped with a camera module, this camera module needs to be downsized. Recently, the capacity of camera is increasing from the existing 12 megapixel to 64 mega and 108 mega. If the pixel increase, the pixel size of the sensor can convert the light to the camera module into an electrical signal become smaller than before, so it generates effects such as dark pixel or bruise on image. This is one of the main causes of failure of camera module. The camera module is manufactured through various processes, and each process needs cleanness and repetitive sorting job for workers. This is repetitive work which we are workers and was apart from monotonous works may be transferred to the next process. So this research developed a fully automated robot classification system based on SCARA robots and organically transfer information for its process and easily reconstruct light without generating foreign objects even in a clean environment of small parts such as camera module. Let's move on to the following stage of the presentation. Methodology. So I will show the success and inline production system using SCARA robot. First, we take a look at configuration of the machine. Figure 3 shows how the arrangement and working processes of the equipment used for inspecting the camera module. Workers need to take out the tray with defective modules periodically and or collect trays that contain good products. At the time, the information on the classified good or bad product number can be reached through the RFID tag inserted in the tray, and the facility can automatically just if the whole process works right. In order to increase the degree of sitting on the inspector socket, the correct location with a separate vision camera preventing damage to the camera module are inspected. Next, here is the structure of transfer units. Figure 4 shows how to insert and discharge the camera module. The pickers are designed to be able to move up and down the cylinder so that they not interfere with each other. And the picker that is inserted into the tester can move up and down. Camera module move between processes in the camera module trace units. which can transfer around 20 units. In general, SCARA robot has the flexibility because it can operate by changing the small or large radius and changing the angle of the arm during rotation. In addition, SCARA robot is designed to withstand 7 kg load, so it cannot only transfer camera module to transfer unit, but also as a device to move the tray to the desired place. Next is the structure of distribution units. Figure 5 shows how the tray containing the camera module supplied to the conveyor is supplied to the facility. Inspect and discharge the tray that has completed in the inspection. The camera module tray is manufactured with designated width and can be linked with previous and later processed using the conveyor. In order to consistently supply logistics, the tray should be transferred to a separate supply area when inspecting an individual camera module to ensure smooth logistics. The information on the process and tray is recorded to the RFID tag so that people in the next process have the status of the process and the information of the contained material. If the supply and discharge line not distinguished, the whole process may be stopped because the goods or batch tray cannot deliver to the next process because of stagnation. The structure of empty supply. Figure 6 describes a device for separate loading and discharging a camera module that is determined to be defective that is excluded from the distribution tray. In order for the facility to operate for the first time, several empty trays must be put into the tray supply device by workers. When an operator puts an empty tray, the facility writes the empty tray to the operating position of SCARA robot and align the position by clamping to fit the tray. When the designated number of the defective material is collected in the empty tray, SCARA robot pick up and using vacuum units of the transfer unit and record the defective name of the material contained in the tray and information on the process intact. Let's move the tray to the next discharge conveyor and move to the next facility. The next facility recognizes that it's the best tray with the information stored in RFID and discharge is immediately. Figure 7 shows a device that aligns the camera module when it is seated in the socket. The connector terminal of the camera module has to be interlocked with more than 18 terminals and 0.03 mm interval so that there are no problems in the transmission of high-speed signal and the power supply. The alignment mechanism of the camera module is effective because the camera module can be rearranged in the inspector without external support. Finally, the process of sorting camera module. Figure 7 shows Figure 8 indicates that the camera module is correctly seated in the socket and is being inspected. For the camera module to be properly inspected, it's go through a lot of processes in order for the signal to be properly transferred from the connector to the memory of the PC. The spine it needs to be checked if it sits properly on the socket, since there are many cases where the connector is improperly connected. In addition, it is important to link the information of the contained material and information with the next process for the transfer of the tray units of the camera module. Now I'd like to talk as our next slide, the result. In general, to produce a large number of camera modules. Several identical lines must be made, which resulted in the reduction of almost 200 workers. In addition to reducing the number of workers due to introduction and automated facilities, it is possible to maintaining the cleanliness of the worker space as a whole under 1,000 classes. The productivity of the line has been reducing the time required for discharging and inserting the camera module by 50% compared to the other orthogonal or articulated robots, as shown in Table 1. By developing a camera module socket that maintains the cleanness of the area where the camera module is produced less than 1,000 class increase the camera module static accuracy from 1 micrometer to 600 micrometer. Self-aligning and correcting at the setting point can eliminate this process, improving the efficiency. In general, SCARA robot has much faster transfer speed than orthogonal or articulated robots, so that other additional function can be added while improving overall system efficiency. By applying the trade, several facility and optimized logistics supply devices were constructed by conveying previous and after process information by the RFID and conveyor structure that can reduce the number of logistic transfer and supply and discharge at the same time. The conclusion: to sum up, existing studies are not suitable for facility mass production because of its slow time in handling products and implementing logistics using a robot. Yeah. In order to make the overall investment and cost area more efficient, to achieve the target performance, SCADA robots application which can improve various functions was suitable and we finally constructed a complete automated line using optimized tools and robots. That's the end of my presentation. Thank you for listening.